All right, folks, let's finish this section on functions in last year's paper, the Gauteng paper. So let's do question 6 now. Um, they've given you a sketch there. Again, I'm going to put the link to the actual question paper in the comments so you can go and see a more accurate sketch of what they were given or what they asked. All right, so they give you two graphs on the same Cartesian plane. There is a straight line, a linear function, okay, with an equation of f of x is equal to minus x plus 4. And they also give you a hyperbola. I've drawn it in blue there for you. And its equation is g of x is equal to 2 over x plus 1 plus 2. Right, so let's answer the questions then. 6.1 for 1 mark. Write down the domain of G. In other words, the domain of the hyperbola, the blue function here, the blue graph. So you need to be careful with this one because a hyperbola has asymptotes. So there are lines that the graph cannot touch, okay? So they are part of the domain for which the graph is not defined. So in order to make it easier to answer this question and maybe others as well, let's draw in the asymptotes of the hyperbola. All right. So here's the equation. What does this plus 2 mean? You need to think back to the mother function. The mother function of a hyperbola, remember, is centered around the origin, meaning its horizontal asymptote is the x-axis and its vertical asymptote is the y-axis. Now, the moment you add a number here, it means that you're shifting the graph up. And if it goes up together with its horizontal asymptote. So our horizontal asymptote is no longer the x-axis, but it is now 2. So I'm going to draw it in green here. That's my horizontal asymptote. Okay. This plus 1 means the graph shifted horizontally. So the vertical asymptote is no longer the y-axis. Now remember, it works backwards. Got a plus 1 here. It doesn't mean that the graph shifted to the right. It means the graph shifted to the left. It always works back to front and opposite. This one is fine. You can rely on the sign here. If the sign is positive, the graph went up. If it's negative, it went down. But with the horizontal shift, if it's a plus, it means the graph shifted to the left. If it's a minus, it means the graph shifted to the right. So this one shifted to the left 1 unit. So let me draw in the horizontal asymptote. It's no longer here, it's now here. Horizontal, sorry, not horizontal, vertical asymptote. All right. So now we can easily work out the domain of this hyperbola. Okay. So remember, domain is all the x values, meaning how far to the left does the graph go and how far to the right does the graph go. So that's an arrow. It means it goes all the way to negative infinity. So it starts at negative infinity. It's always a round bracket. I'm going to do it in interval notation first. So it comes this way, but it is stopped by this line here. So it goes from negative infinity to negative 1 to anything less than negative 1, hence the round bracket, because we are not including negative 1. The graph is not defined at negative 1. Union, meaning all. What happens after negative 1? All right, the graph continues. Okay, so from negative 1, the graph continues excluding negative 1, and it goes all the way to infinity, positive infinity. Right? I wonder if you can see that. Because of the glare, let me write it slightly lower. So it's from negative infinity to negative 1 union, negative 1 to positive infinity, and just add this part that it's all the real numbers. It's all real numbers. Okay. Or you can write this in this way. You can say x is an element of real numbers. So it's all real numbers, but x cannot be equal to -1. That's another way of writing that. It's saying exactly the same thing. So that is one easy mark. Okay, let's look at 6.2. Let me do it here. 6.2. 6.2 says write down the equations of the asymptotes. Very easy. We've already drawn them. So let's begin with the horizontal asymptote. If it's a horizontal line, remember it will always be y is equal to wherever the line cuts the y-axis. Okay, so it's y is equal to 2. That's the horizontal asymptote. The vertical one will always be x is equal to wherever that line cuts the x-axis. So it cuts my x-axis at -1. That is the equation. Okay, right. Now they want us to work out in 6.3 the coordinates of point D, and D happens to be the point of intersection of the two graphs. Right? Let's work out the coordinates of D. Okay. How do you work out points of intersection? The point of intersection is the point where the graphs are equal to each other. If you look here, the y's of both the graphs are equal to each other. For example, at point D, the y of the straight line is 3. The y of the hyperbola is also 3. Okay, so at the points of intersection, for any question, whenever you are asked for points of intersection, make sure that you've solved for y's in both, and then you equate them and you solve for x. Let's do it. Let me squeeze it in here. Yes, let's do it here. So at the points of intersection, I know that my f of x will be equal to my g of x. Okay, what is f of x? It's given. So minus x plus 4 is equal to my g of x, 2 over x plus 1 plus 2. Now we need to solve for x, right? Grade 9 equations, I've got a fraction here. I need to get rid of this fraction. How? By multiplying by the denominator. So let's do that. So I need to multiply this by x plus 1. Okay, but whatever I do on this side, I must do on that side. So I must actually do this to everything. Okay, so let's go. Minus x plus 4. Okay, I'm going to multiply that. Let me write this in red. It's multiplied by x plus 1. I'm multiplying everything on this side by x plus 1. Okay, which is equal to 2 over x plus 1. Okay, multiply that by x plus 1. Do not forget this 2. Everything must be multiplied by x plus 1. Okay, so what's going to happen here? These will cancel. We'll have no fraction, which is what we want. So let's continue now. I've got a binomial times a binomial, so we can FOIL it out. That times that is negative x squared, negative x plus 4x plus 4, which is equal to 2. Distribute the 2 into this bracket, plus 2x plus 2. Okay. As you can see, it's going to be a quadratic equation, which is not surprising. We're going to end up with 2 solutions. Why? Because the graphs meet at 2 places. So one of our solutions will give us the x coordinate of A, the other one will give us the x coordinate of D. Okay, so let's make everything positive. I'm going to move everything over to the right hand side, make it equal to 0. Remember, you make quadratic equation equal to 0, and then you factorize. So let's move these guys over. Remember, when they move over, their signs change. Sorry. These guys stay the same because they didn't go anywhere. Okay, let's add like terms. 0 is equal to x squared. 1 minus 4 is minus 3, plus 2 is minus x, minus 1, minus 1x. And then let's add the constants. That's minus 4, plus 2 is minus 2, plus 2 is 0. So this is what we're left with. Factorize now. I'm taking out the highest common factor, which is x. So whenever you have two things multiplied by each other, giving me an answer of 0, it means that x is equal to 0, or x minus 1 is equal to 0. That's done. So it means that x is equal to 1. So we've got two answers. We are looking for the coordinates of D. So which of these is the x coordinate of D? Is it this one or this one? Can't be this one, okay? Because this D is not on the y-axis, so it has to be this guy, right? So let's continue this here now. Right, so I know that this D will be 1 and something. We need to find the something, which is the y-coordinate. How do I find the y-coordinate? I take this x is equal to 1 and substitute it into any one of these, okay, because both of them go through D, okay? So it's always best to go for the easier one. This one is going to be easier to work out. So let's do f. So we want to know what is f equal to when x is equal to 1. In other words, what is f of 1? Okay, so I'm going to put a 1 wherever I see an x. So it's minus 1 plus 4, which is equal to 3. Okay, so this means that the coordinates of D are 1, 3. Okay, I hope that makes sense. Please feel free to comment, ask questions in the comment section. I'll try by all means to respond whenever I can. All right, so those are all the functions questions in last year's Gauteng paper, and it was a total of 38 marks. So functions count quite a lot in your papers. All right. Thank you.